So hello, Prof. This is our group project presentation. We're group one, Hans, Bruno, Jessica, and Joel. And we'll go ahead and introduce the project for you. Next slide. Perfect. So the data that's provided is related to the direct marketing campaigns of the Portuguese banking institution that's provided to us from the files that you sent for the assignment. It's, as we know, it's called the bank CSV. The data set contains personal information such as balance, age, loans, etc., which are the relevant attributes that we're able to use to train the model and help the bank predict whether the clients would subscribe or not. So the problem or the questions that to be answered is which classification model is better to predict if a customer will subscribe to a term deposit or not. As for the methodology and experiment design, these are the main points that we want to put up there, which is removing unnecessary attributes and row with incomplete inputs. As according to the instructions, we're supposed to remove the P outcome attribute as it doesn't have any relevant data that can be used for the prediction. And as for removing the unknown entries as well, as it is an incomplete row and it it wouldn't be helpful in terms of training the data. And then as regular as we learned from the class, it's going to be an 80-20 split for the training and testing, 80 for the training and testing for the 20 for the testing. We also wanted to compare both the unclean and the clean data just to give out the statistics. And also we will be testing 4 classification models for this project, specifically C3, J48, KNN, and the linear classification. These are just some of the stats that we've come up with. As for the number of unknowns, it's 14,304, and then the percentage of the unknown is 146, but I believe it's 46%. It's just that we didn't do the math and just copied and pasted from the R file. And as you can see, you can just see the number between the difference between numbers the clean data and the dirty data. And this is something that we found online. It is from the website called researchgate.net. We believe that it's a flow chart or step-by-step methodology that we're able to follow and kind of align with our approach to this assignment. So as we know, data acquisition is the given data set, bank CSV, feature extractions, removing P outcome, as I mentioned, and unknown variables, model implementation, testing, and so on and so forth. And again, going back to the stats, these are just the main difference between the attributes for the clean and unclean data. As you can see, the numbers. We have the mean here, median, and standard deviation as just for the average of each. And these are also just some charts that was instructed to be displayed for the presentation. There's not a lot of difference. And honestly, as for the y-axis value, we believe it's just the number of, or the specific let's say row for each plot, but again, we're just here to compare the saturation of the number of plots in between the non-filtered and filtered data set. And starting with the first classification, we have C3. Just to have a brief explanation of what C3 is, as we know, it's the most common classifier that we consider known to many, and especially it can be considered a decision tree due to its leaf nodes and root nodes. As we know that we use entropy to determine which attribute is best to set as the root node and which is used for the leaf nodes going down the tree. And these are just the numbers for the stats of the confusion matrix produced by R. And we also did the calculation. It will be available on the document, and the true negative and true positive and false negative and false positive. Moving forward to J48, again, just a brief explanation. It's the decision tree. J48 can be applied on any data set, which enables one to predict the target variable of a new data set record. This is done based on the ID3 iterative dichotomizer, 3 algorithm. This classification tool is a very useful tool analyzing the data categorically and continuously. It's very similar to C-tree. Again, this is just the confusion matrix produced by the R file, and the calculations are also available on the document report submitted. Moving on to KNN. KNN, also known as the K nearest neighbor algorithm, is a supervised learning classifier which aims to recognize the patterns to identify the best possible similarity. It is commonly used to classify the problem by learning an analogy where the KNN will perform assuming each data point falling close by and some scattered. And we know that KNN makes it easy to understand the algorithm for non-linear data. And as for the same as for every classifier, the calculations are available on the document. And lastly, we have the linear classification. The linear classification is a classification method that uses an object characteristics in a data set to identify which class it belongs to. The method identifies which class an object belongs to by developing a linear combination of characteristics of the dataset. The general equation of a line is y/mx plus b, as discussed in class. In our project, we used R to develop it, so it makes it easier for us. And moving on to the accuracy comparison that will be discussed by Kruno.
Okay, so as you heard my peer Hans that describe a lot about the different classifiers and different matrix that we used, I'm gonna go in deep with the comparison part. So if you look at the first comparison as with the accuracy, where we have 4 classifiers C3, J48, KNN, and linear, which is calculated by taking the correct amount of predictions, including true positive and true negative, and dividing them by total predictions. If you look at our bar chart, we can analyze that C3 is the highest with over around 80%. Then we have J48, which is at 87%. Then we have KNN just a bit below that, which is 85.8, and similar linear is at 85.5%. Our next comparison is for the error rate comparison. Based on the graph, it is calculated by subtracting 1 from the accuracy. Once we did those calculations, we come up to the numbers that shows that C3 is around 12.1%, which is the lowest one. Then we have J48 as 12.9%. The third one is the linear, which is a bit higher than C3 and J48, which is at 14.1, and similarly KNN is close to there, which is 14.5%. The next one we have is the precision comparison. Precision comparison can be calculated by dividing the true positives by adding the true positives and false positives. In the precision, we have the highest one is the KNN, which is at 87.8%. Coming down from there is linear, which is 71.5%. C3, which is at 60.9, and the lowest one we have is 58% from J48. The next one is the recall comparison. Recall comparison is the ratio of correctly classified positives divided by the sum of correctly classified positives and incorrectly classified negatives. After comparing and calculations for the recall comparison, we come up to a bar graph that states that Canon is the highest one at 95%. Coming down from there is the C3, which is at 50.7%. Below that is J48, which is closer to C3, which is 46.8. And the lowest one is the linear classifier, which is at 0.084%. Last one, we have the F1 score comparison, which can be calculated by twice of precision and recall divided by the precision plus recall. The highest one for F1 score we have is a C3, which is 55.3%. Below that is J40, which is a bit closer, which is 51.8%. And the major difference with the linear and Canon, with Canon having 38.7% and linear having the lowest one at 15.1%. If we compare all the 5 metrics, we come up to a conclusion that C3 is the one that banks should use in order to compare if a client will be choosing to have a safety deposit box or not. Conclusion, that the C3 is the one because C3 has the highest accuracy value of 87.8% along with the FN score of 55.3%. And thank you for coming for the presentation, Professor. Based on all the numbers and calculations, we believe C3 is the classifier that we should be using. And you will find more detailed calculations and answers in a report. Thank you for coming today. Have a wonderful day.
Thank you.